Okay. So you should be able now to see my presentation in full screen. Yes,
Yes,
perfect.
we do.
Okay, so again, welcome to this 10th community call of OpenAIRE Connect. The agenda for today, as Merrily already introduced, is that we are going to run through some novelties of the OpenAIRE Connect service. And then we will dive into the Scilake project with Thanasis and Andrea. And we will have time for questions both on the new releases of OpenAIRE Connect or the Scilake project and how OpenAIRE Connect is used in this research project. So let's start from the new functionalities that we have introduced last week on all OpenAIRE Connect gateways, which is the possibility to upload an open access version of a closed publication directly from the gateways. So, and this is available also on the main portal of OpenAIRE. So you can do that also via OpenAIRE Explorer. So if you come across a publication that is closed, like this one, which is available via a journal, but it's not openly accessible, you can you will see the possibility to upload an open access version. So if you are an author of this publication, or if you have the open access version of this publication, you can provide an open access version so that also other people can access it. So if you click on upload now, you will be asked to upload files to ATHENA records. So if you click on upload files to deposit, you will be prompted to upload a file from your computer. You can select one, and then you're prompted with a set of metadata that is taken directly from the metadata that you see in the gateway. So you have pre-filled title, the publication date, the creators, so the authors, the license. And if you're doing this within a Connect gateway, then you can also upload it into one of the Zenodo communities that are related to this research community. So in this case, I used BeOpen, which is research community of the Scilake project that is related to transport research. And of course, I'm sorry, let me go back. There is a button to submit to Zenodo here beyond below the list of Zenodo community. So, and when you press it, you are basically sending all the information to Zenodo, and you will have the possibility to review and edit the metadata directly from Zenodo. You can do the same process also if you go into your upload section. So if you hover your initial on the top right of the gateway and you go to My Uploads, you will have the list of all the publications that you have uploaded. And you can also click on this box in order to see which are your publications that are closed. So in this case, if we do it with the account of Paolo Manghi, then pressing the button will run a search that gives you all the closed access publication that you have. So for each of them, you can go, click, and share the open access version to everyone. Another functionality that we have introduced is for gateway managers. So gateway managers are the experts that configure the criteria by which the research products are included in a gateway, so that because they are relevant to a research community. And one of these criteria is the affiliation. So we can say, in this case, for example, that any research products that is authored by someone who is affiliated to the Central European University, then it should be included in the gateway. this visualization for managers was not available before, so they need to ask me to double check the list of organizations that were considered, and we improved the administration dashboard so that managers now can check which are the organizations that are included. But we did a lot of other things since March 2025, which is the last community calls that we had. And as usual, you can check the changelog on the OpenAIRE catalog, and you can also check out the Trello board where I keep the roadmap of the service up to date. And you will find the links both to the changelog and to the Trello board if you go to the website of OpenAIRE Connect, which is connect.openaire.eu. An interesting feature that we experimented with Scilake, especially with the transport research and the neuroscience communities, is the concept of subcommunities. So what we will do soon is to release the possibility for the managers of the gateway to not only specify the criteria by which a product is relevant for the community, but specifically with which subcommunity. So for example, the gateway manager of neuroscience will be able to say that all the products from this specific journal, for example, not only is related to neuroscience, but it's related specifically to the subcommunity of neuroinformatics. And this is a nice feature that we developed in the context of the Scilake project. So, said that, I think I can leave the floor to Thanasis that can present Scilake project in more details. So we'll stop my sharing.
Okay. So I hope you can see my screen now.
Yes, thank you, Thanasis.
Okay. So I will give you a very quick overview of the Scilake project. The main tagline of our project is democratizing and making sense out of heterogeneous scholarly content. And I will first start providing some insights about the motivation behind the project, and then explain a little bit about its objectives, the current results, and provide the background about the pilots, so that Andrea can then discuss in more detail how they used the OpenAIRE Connect for their own pilot. So, first of all, our project is an EOS related project, a project about related to the European Open Science Cloud, which is an ecosystem that aims to support open science in Europe. The main motivation behind the project was that the realization that although there is a plethora of scientific outputs out there and a variety of scientific knowledge produced by researchers in the previous years, there is also a fragmentation in the way this knowledge is shared and made available to everyone, the researchers included. So scientific knowledge is scattered across diverse sources, diverse formats like datasets, software, workflows, publications, but also the description of those elements is not always unified and homogeneous. The file formats are different, the metadata formats used are not the same, and sometimes even the language used is different because not every there are a lot of different research outputs that are described in other languages than English. So given this situation, although there is this vast amount of knowledge that exists out there, it's not that easy to access it and process it and get insights based on it. So this is one very important problem. The second problem is that the communities that are producing this knowledge involve researchers that, although they are experts in their own domains, they are not experts in scientific knowledge management approaches. And because of that, they are not involved in the process of, they are not involved a lot and actively in the process of making this content available to everyone in a way that can be useful and easy to analyze. And this situation becomes even worse because there is a lack of tools and toolboxes that can help this kind of domain experts to create their own scientific knowledge graphs. A scientific knowledge graph is a structured model, a structured approach that can help the domain experts to publish the domain expertise, the domain knowledge in a way that is easy to consume by researchers, but also by services and programs. So although this technology exists and it could be beneficial to address some of the problems that we already mentioned, it's not that easy for domain knowledge experts that they are not that advanced in technical aspects and relevant technologies to reuse those tools and make a difference in the way that the domain knowledge is served. And finally, we are not talking about a small number of research products that include the knowledge related to a domain. Based also on the experience that we got from the project, it seems that even for relatively small domains, we are talking about millions of research products that are potentially interesting and relate to this particular field, or at least hundreds of thousands. Now, Scilake aims to address these challenges by creating a unified, interoperable, and accessible ecosystem for scientific knowledge to enable researchers to discover insights and make informed decisions. The whole idea of the project was to have the knowledge management experts to work together with the experts from various domains, scientific domains, and try to improve the knowledge management tools, make them more accessible, inform the experts about them, and help them create domain-specific scientific knowledge graphs and build some useful applications on top. As you can see, we have 13 partners in the consortium, coming from different areas of Europe, covering from the north to the south, and 8 of them are technology providers, and 5 are representing scientific communities that are acting as pilots from the technologies created or improved in the context of this project. So the main service that Scilake is building is the so-called Scientific Lake service. This is more or less a toolbox of core components that the researcher can combine to create, interlink, maintain and query domain-specific scientific knowledge graphs. There is an array of such components that create this scientific lake service. There is a data catalog. There are some tools that are assisting researchers to create their own knowledge graphs or to enrich them with additional links or links to other knowledge graphs. And there are also tools that facilitate searching and navigating into this scientific lake. And on top of this foundational service, we plan to build some value-added services which will be customized to particular domains, particular disciplines, and can demonstrate how the concept of the scientific lake can work in practice and bring some benefits to the respective research communities. At the time of the proposal writing, we had identified 2 main such value-added services, one around scientific knowledge discovery, and the second one about assisting reproducibility. So both of them are building upon the foundational layer of the scientific lake, and they are using it to produce some tailored functionalities to researchers of particular domains, helping them identify valuable research objects or to assess the readiness of those objects in terms of reproducibility. Now, the whole idea is that it is depicted in this diagram here. At the left, we start with a domain knowledge that consists of different publications, data, databases, even some scientific knowledge graphs that may pre-exist in the area. The domain expert identifies those resources, and then the scientific lake service is used to import and transform this data into a format that is appropriate for queries and analysis. The data from the domain knowledge are combined with metadata from the OpenAIRE graph, and this creates the domain-specific SKGs. Those SKGs are created in a way that some guarantees about interoperability are met. More specifically, there is an RDA group that is producing the SKGIF interoperability framework for scientific knowledge graphs, and the domain-specific graphs that are produced by the Scilake ecosystem, they are trying to be compliant to that model, to that specification. And then the scientific lake also has another set of components that can help, that can facilitate data accessing and querying. Then the application tier is related to the value-added services that I mentioned. These are closer to the end user. They are UIs or APIs that are consuming contents from the scientific knowledge graphs and provide some useful functionalities to the end users, which in our case are researchers from the particular domain. Now, something that I would like to mention is that this is more or less the ecosystem, the environment. It is a high-level picture of that, and each of those boxes here involves the deployment of different components. And according to the specificities and the needs of each community, different tools may be used to perform the various tasks. So the domain experts, together with the technology experts, are deciding based on the current needs which subset of the toolbox of Scilake toolbox should be deployed for this particular case. So you can think of this as a toolbox, but also you can think of it as a federation because not every component is installed on the same node. Different nodes, each of them undertaking a different part of the respective processing, can coexist. And something that I would like to mention here, since we have this picture on the slide, is that the role of the OpenAIRE Connect is related to this important transformation process. So the OpenAIRE Connect was used so that the domain experts could more or less define which part of the OpenAIRE graph better relates to their own domain, which part of the graph, which subgraph is the most relevant or interesting to the particular community. So the researchers exploited, leveraged the community definition components of the OpenAIRE Connect to create a relevant community. And based on those definitions, we had created some subgraphs of the OpenAIRE graph that were merged together with the domain knowledge that came from publications or from existing knowledge graphs and databases to create the domain-specific scientific knowledge graphs. So more or less, this was the way that the OpenAIRE Connect was used in the context of Scilake by the pilots. Now, this ecosystem that the project is trying to build involves multiple components. Each of them can be useful in different use cases. So the end user should select which of them relate to their particular needs. The implementation is relatively easy, so the ecosystem can be deployed on a computer cluster in an easy way. And it is customizable, each component is customizable so that it can address specific needs from the respective communities. And finally, before giving the mic to the next speaker, I would like to provide some context related to the pilot case studies. We have selected 4 domains, the neuroscience, cancer research, transportation research, and energy research. Each of them has as their objective to create a knowledge graph that includes domain-specific knowledge based on the previous process that I mentioned and using the Scilake components. And on top of that, to demonstrate the value of those graphs, they will also experiment with the value-added services we mentioned and provide some feedback that can help the technology providers of the project to better understand which are the strengths and the weaknesses of their approaches. So the pilot role in the project is very active. They were active from the beginning, providing feedback to the design and development processes of the technology providers. And at the point that we are now, which is about 6 months until the end of the project, we are in a phase where they are giving feedback for the prototypes that the various components have that we have for the various components and testing them in real life use cases. And with that said, I think I can give the mic to Andrea. I will stop sharing.
Okay, thank you, Thanasis. So with your presentation, you already introduced a lot of information related to Scilake and also to the energy pilot. So thank you for this. Now you should see my screen.
Yes,
Hello
Andrea,
again,
thank you.
everyone. Okay, so I'm Andrea Salmi, PhD and research assistant at the University of Applied Sciences of Valais in Sion, Switzerland. And I'm gonna try to introduce you to these different points. Yeah, first the role of energy pilot in Scilake, which will be brief. I will try to define what is our knowledge space for the energy pilot, which are the expected outcomes in relation to what is the gateway and in OpenAIRE. And then we'll see a bit briefly the process of the gateway configuration for the energy pilot. In the end, we'll see some brief conclusions and ideas for development in relation to the gateway configuration. So first, thanks to Scilake, we'll probably, I would say probably, be the first open source energy science knowledge graph that broadly address energy. And we have a portal on OpenAIRE that's tailored to the gateway that you can see on the left. It has already many millions of results. And in this portal, you can test our first way of tailoring the subject of our field by doing the gateway configuration that we're going to see later. So in relation to the project of Scilake, we'll have a beta for probably for August or a bit later in 2025, and we'll end the project in end of 2025, early 26. We're also going to participate to a couple of conferences that you may know, the OSPER conference in September in CERN, Switzerland, close to Geneva. And the other is the ECMP of the European Union in October 2025. So you already know partially Scilake. We are between this wonderful group of partners, and our role is to be the energy pilot, the representative pilot, but also to lead the other pilots and relate with the many work packages, which mainly deal with technical, I would say, delivery of different services related to Scilake. So within this consortium, we try to bring added value to our specific subject and try to understand how it relates not only to research, but also to other fields that are outside of research, to deliver a complete added value through the research project. So how OpenAIRE relates with Scilake, you have already seen it in the presentation of Thanasis. It really relates with the input and the open source publication that we see and we use in the creation of science knowledge graph, and through all other added value services that you see on the right. But today we're going to see a bit better how we actually can improve, how we tried to improve the selection of the knowledge space for our pilot. So generally, it's a bit broad to define the field of energy. To be more specific, our pilot is partially focused on regional energy planning compared to the field of energy. Why? Because all the keywords that you see on the left are partially coherent with our topic. Instead, the one that you see on the right, they are closer. This can be summarized in these 3 points: that we are closer to what is optimization rather than innovation. We also closer to practice than theoretical research. And our main objective is to boost the scale-up of sustainable development in general in the field of energy. That's why we we start to shape the core of our knowledge space from these keywords, from these subjects, rather than the others. The step is also has been theorized while drafting the role of different tools and services in Scilake. So here you can see different level of knowledge within the energy pilot, starting from broader fields than energy, which relate to engineering and technology, getting to the field of energy. And I mean energy in terms of use of energy for development, for everyday life, for the society, and not other types of energy more related to physics or chemistry or psychology. Then there are many subjects that you can see, for example, in level 4, like energy policy, renewable energy, and getting closer and closer to specific and frequent keywords that are used in the field of energy. So in relation to the Scilake projects, we collaborate with OpenAIRE to improve the portal of energy planning. Now we are probably at the fifth relevant iteration, more closer to a fine-tuning of what is the energy portal. And what have we done? We've done mainly the configuration of the data sources, subject that are field of sciences and sustainable development goals. There's another communities and the advanced criteria. So today I'm not gonna focus, for example, on the different customization or menu and interfaces of the portal, but I'm gonna deal with the core and the input that the energy gateway will provide to the users. You can see that the number of results, depending on the iteration, was varying between, it was in the beginning 11,000 to a few millions. And then after getting enough number of results at the second iteration, we tried to customize the gateway to reduce the results and reduce the noise, to have less out of scope results. The customization of the gateway relates to our development. You have seen that our first objective is to create a science knowledge graph related with the energy pilot, and also to provide a portal that focus on energy planning, which is in scope and also relevant in providing a research assessment of open source research. And then our objective is to understand if what we produced can be applied on real research questions across the different tools, across the science knowledge graph, across the gateway, but also across other tools. And there are two other objectives that would be, for example, test these tools in subsets. So I think that what Alessia showed us before for other pilots in relation to the subcommunity is really interesting, because these relate with also the interest of discover new research questions of sub-subjects. For example, it could be energy planning itself compared to only energy, but also other subfields like urban health or age-friendly environments or data center that you would like to test to understand its power, but also to relate to other projects. Then the added value that is provided through Scilake relates also to other tools. For example, the extraction of entities that can recognize in the text case study areas, so their geographic extent, can extract the location of publishing institutions of papers, and also relates to taxonomy in the energy field. Extract the dates of the case study, or even link the research with the respective regulation framework, depending on the place where the studies are located and their field. So with this objective in mind, we have to understand what we need to produce. We need to produce and to fine-tune a gateway of energy planning that produce results that are partially connected with other fields, for example, to discover transdisciplinary subsets, but are really strong in defining the fields of energy planning so that the noise is reduced as much as possible. So our expectation of defining the knowledge space was really simple: to have a result that is really in scope, related just with energy, and then maybe relate some other fields, some other keywords that are partially in scope, and try to avoid everything that is out of scope. But in the end, in the reality, we observed that is way more difficult. The definition of such a broad topic can be done also by identifying a lot of different sub-keywords, sub-subjects, rather than being general and broad. And that's the same for what we partially need, and also for what we really do not need. So this proliferation of numbers in terms of fields and subfields tried to be challenging, and challenging in terms of shaping the energy planning gateway. So as I anticipated before, the idea was to identify an area that's really in scope to reduce as much as possible the noise, but willing to discover also some transdisciplinary research questions. We needed to expand it as much as possible. So in the first configurations, we've done really little. What you see now for the energy gateway relates with 26 data sources, so journals, with 2 subjects. So 1 field of science and 1 science development goals, 12 Zenodo communities, and 7 advanced criteria. Thanks to the help of OpenAIRE, so in particular thanks to Miriam, we were able to configure the actual portal gateway of the energy pilot, and also this was done using the OpenAIRE Explorer advanced search. So with this tool, we were able to test criteria by criteria, which is the partial impact of all our choices to the configuration. So in the first configuration, we just related the publication with our projects that are related to OpenAIRE. So we had really few thousand results. The projects were NR maps and auth maps, just for citation. And then in the second configuration, we added journals. We selected journals, subjects, and Zenodo communities, reaching a few million results. We tried to shape this result, and we added advanced criteria. And at this time, we were doing a mistake because we added advanced criteria without removing the subject that we shaped in the advanced criteria. So at this time, at the third iteration, the number of results increased. At the fourth iteration, we were able to remove also these side subjects that were included in the criteria and provide more context in the advanced criteria. And in the end, in the last configuration, we were trying to test some intensive, I would say, configuration of advanced criteria. How do we do it? So the idea that we are testing is to select for our pilot a large number of keywords, for example, 100. And then depending on the different subject that we would like to shape, to tailor, we select the keywords that are more relevant to this subject, and we use them to reduce as much as possible the size of each of these criteria. This is in parallel with the test on OpenAIRE Explorer to understand how much results we expect to have and if the quality of results is enough for us. So with this, we reduced from 5.5 million to 4.9. And for example, we switched from the simple subject of using energy, the word energy, in shaping this subject to this list of 30 keywords. And this was done for 7 criteria. I think we're gonna do it for more criteria. And maybe we're gonna even increase the number of keywords, trying to add more specific keywords and be less broad in terms of defining the subject of energy. So in the conclusion, the idea that sometimes we have in trying to configure the gateway is that it's actually impossible to perfectly define and to have no noise at all. But we try to reduce as much noise as possible. And also think about how you plan to use your gateway, because depending on your objective, you may look for something that is more precise or something that is larger, for example, to connect with a transdisciplinary research. In the ideas for development, since I see many of you that are also in OpenAIRE, shipping the advanced criteria was a bit time-consuming. So having something like a table or something that can be pasted for multiple criteria would be more useful in trying to provide a better configuration. And then also it would be useful to understand directly, maybe in the gateway, how the different choices impact the gateway. So I don't know if it would be possible, but I know that you can explore and get this information. Then it would be useful also to improve the input for journals. I've seen that most of the journals that we selected in our case have just few outputs, while maybe also the communities in terms of data sources may bring some noise, and where the sources that were bringing more content, it was less relevant, but also less characterized with a few information and few metadata. Also, maybe it would be useful to revise the relevance algorithm that is maybe not transparent, so we can better understand what we're actually seeing in terms of relevance. And in the end, since this process is more iterative and we are getting better time by time, it would be useful also to plan or receive a notification about the when the gateway is published, usually each month. So with this, I hope I gave you some useful information, or at least an experience return from the side of the energy pilot, and I can leave the time to question and answers.
Thank you, Andrea. Thank you, Thanasis. And Andrea, what you said is very useful, and it was very interesting. So understanding how you approach it, the process of defining the scope of the gateway was very interesting and very detailed. And for sure, I want you to send me the slides, and we share it also with the other participants, because I think there are many suggestions for improvements that I would like to add to the roadmap of the service. So thank you very much indeed. There are any questions from the audience?
Yes, Alessia, I can see a question on the chat from Françoise. I'm wondering if it is possible to get the inputs from a specific journal, providing simply the ISSN number of the journal we want to the gateway.
Currently, for sure, you can search for the name of the journal and select it. I do not remember if you can also search for the ISSN.
Not
Probably.
so far. Not so far.
No, but when you go to the data source and you run a search, maybe you can search for the ISSN and get the journal to select. So if this is not possible, this is something that we can for sure investigate. Or it could be also an option, Miriam, if we could allow, the upload of a CSV with a list of ISSN.
Yes.
This could also be an option, yeah. So thank you, Françoise, for the suggestion.
If you want to do this, we have to extend the backend.
Yeah, yes, of course. So if there are no other questions, I have a couple, if I may. So Andrea, so the idea, if I understood correctly, the idea in Scilake is that a scientific, a scholarly knowledge graph like OpenAIRE can provide bibliographic information about research, data sets, publications, and so on and so forth. And then there could be domain-specific information that can be integrated with that. So in your pilot, are you doing this kind of integration with other specific data sources, or are you focusing on the scholarly knowledge graph?
There are integrations for sure for what concern the added value services, because it's necessary. But for other services, in particular for the science knowledge graph, I don't think so, but maybe Thanasis could correct me.
Yes, in general, the idea is what you described, Alessia. So those domain-specific knowledge graphs go beyond the main research products that are the focus of general purpose knowledge graphs like the OpenAIRE graph. So ideally, For the different pilots, what is needed is to combine the information that they can get from the OpenAIRE graph with information that comes from other sources. In the case of the energy pilot, as far as I remember, there are no such sources to be included, but other pilots had some. And also information that can be extracted from full texts of publications by some components that Scilake partners are building, like named entity recognition components, like those that were mentioned by Andrea, etc. So more or less, the pilots get basic scholarly information from the OpenAIRE graph and combine it either with information that comes from already existing data sets and knowledge bases, or with extracted information by some Scilake components that may implement text mining or named entity recognition approaches.
Thank you, Thanasis. Thank you, Andrea.
So I may have a comment related
Please.
to your first comment. So thanks. I hope it's going to be useful. I think that maybe this would be the opportunity to collect other feedbacks from other pilots within Scilake or outside in other projects, and maybe try to shape, for example, a very simple page, PDF, or whatever you would like to add. That's maybe a guide as soon as a manager start shaping the gateway, trying to optimize and also reduce the many mails that are going to send you in a second moment.
Yes, I think this is a good idea because we have a guide for gateway managers that goes into the details of all the options that are available. So that if you don't know how to do something, you can go to the Open Plateau platform in the guide for gateway managers, and you can find a really step-by-step guide on how to use the functionality. But what you presented is really the concept, is the methodology. So having a page that describes a possible methodology, all the possible challenges that a manager have to face in order to define the scope of the gateway, I think it would be very useful. Yes.
And within the group of 52 communities, do you think that the project of Scilake is similar to other projects that participate? So this conclusion, these lessons learned could be useful, or there are others?
No, yes, I think yes. There are Connect serves very different use cases. So the cases of thematic communities like yours, but also university alliances or research infrastructures. And let's say these three types of users, let's say, face different challenges. In the case of thematic communities like yours, we think that it's the more complex case, because when you work with the subjects, as you've shown, the same subject is used in different domains. So you cannot just say energy and you take everything that is about energy, because you will include physics because of dark energy, for example. So I think it will be useful also for others, not only within Scilake.
Great, thank you.
Marily, I think we ended our time.
Yes, and there are no more questions. So we can conclude today's community call. Thank you everyone for joining us. Thank you, Alessia, Thanasis, and Andrea for your presentations. And we'll see you at our next call in 4 months. Have a nice
Thank you.
rest
Have
of
a
the
nice
day.
day.
Thank you.